right, welcome everybody. I hope you're having a great reInvent and that you are here and ready to solve some of those large-scale data access challenges with Amazon S3. Now, the first thing you need to know here is you're going to hear a whole lot of different use cases and strategies for these large-scale access challenges. One thing I want you to know is that nothing I'm going to talk about in the next hour is a hypothetical. So let me tell you a little bit about who I am. My name is Becky Weiss. I'm a senior principal engineer at AWS. My area in AWS is what we call security in the cloud, so the controls that customers have to be able to control their data and workloads and resources and so forth. So, that is very closely related to these challenges of data access in S3 and other services in AWS. And I often talk to customers about their use cases and how they have this challenge and this scale dimension and that scale dimension and how to solve them. And what you're going to hear about in the next hour are various, they're not all created the same. Various patterns of use cases and the strategies that are the best fit for those. These are strategies that I have seen customers use successfully. So that's what we're going to talk about today. And in our story today, the large-scale data access challenge that we're going to look at today, it all kind of is a story that sort of looks like this. You have an S3 bucket, or maybe a few S3 buckets, or maybe a lot of S3 buckets. And inside these S3 buckets, you probably have your data organized in data sets that probably kind of looks like this, except maybe many, many more of these. So over here, you have folders. Now, I used the grosser quotes there deliberately. You have a red data set, a yellow data set, a blue data set. Now, there is no such thing, if you know a little bit about how S3 works and what it is, it's object storage. There's no such thing as a folder quite. In S3, it's object storage. You store your data in S3. You store it as these object names. Forward slashes are an acceptable character in these object names, but they also make for useful organization and wildcarding. So most of our customers do, in fact, think of folders, even though they're not actually technically there in S3. And, so I've got red, yellow, and blue, and I probably have different entities. Now, they're shown on the slide as users, and they could actually be human users, but they could also be machines, applications, different groups of entities that respectively need access to these different data sets in S3. I've got red entities, I've got yellow entities, I've got blue entities, each respectively needing access to its own folder. Now, of course, this is very straightforward. If you know what you're doing with identity and access management, you probably know how to deal with this. But what about when there's a few more than 3 of these folders in here? So that's what this whole hour is about. We're going to talk about there are a few different scale dimensions that might be in play here in your use case. We're going to talk about the various ones and the strategies that are best used for each. So we're actually going to talk about a few different kind of categories of strategies. I'm just going to warn you, we're going to cover a lot of material here in the next hour. We're actually going to go pretty fast because there are actually a number of strategies, and we're going to go into some depth. You're in the right place if you are a builder. I'm a builder too. We're going to talk builder to builder. We're going to go into details. So if you like details, you came to the right talk. And so this is kind of how we're going to structure the next hour. We're going to start at the bottom with the identity and access management basics. Now, I will say that I am assuming a little bit of background with identity and access management here. If you're new to that, that's okay. I am going to cover the basics quickly. But I will say to those of you who don't have those basics, my own personal advice on your cloud learning journey, getting good at identity and access management, we have plenty of content to help you with that. Getting good at identity and access management is your single most leveraged skill, I think, in AWS, because if you understand that, that's the permission system to everything, not just S3. It'll really help you, it'll give you actually a really good frame of reference for learning about anything that happens in AWS, all these services. But I will do just a tiny bit of basics here just to get us started. Then we're going to talk about strategies for applying those basics and how much scale you can get out of those. And we're going to talk about, well, what if you're past the limits for those strategies? What can you do next? And we'll talk about technology such as S3 access points and a session broker pattern that I see a lot of customers build successfully. We'll talk about what they do and maybe what you can do. And then over there, it's on the side because it's not really on the same sort of scale complexity axis. What if your data is shaped like analytics data, structured data in S3? And we'll talk a little bit about the AWS Lake Formation service and when you should be mapping that to your use case. So here we are. We're going to start at these basics, and I'm going to go through them kind of quickly. So at the core of any request for data to S3 is an API request. Here's the S3 get object API request. That means they're going to be reading some data from this object. They ask for the bucket, they ask for the key, and the call is always, this authenticated API call is signed by the credentials of this IAM principal, this identity. And they're trying to reach a particular bucket in a particular region of Amazon S3. In this picture, I have shown the caller and the bucket in different AWS accounts, although we're going to be talking both about the case where they're in different AWS accounts as when they're in the same AWS account. And for authorization, of course, every API call to AWS gets authenticated and authorized through the IAM system, through these systems of policies. Well, there's actually two policies in play when we're talking about a request that gets made across accounts. The IAM principal is going to have some policy on it that says what it can do, that's issued by the account that owns it. The S3 bucket might also have some policy on the bucket that says who can do what to it, that's issued by the account that owns it. So let's take a look at one of these. Policies. So over here, this might be a policy that could appear on an IAM principal. If you've seen IAM policies before, you'll sort of recognize what you are seeing here. It says this caller is allowed to get object, that means read stuff, put object, that means write stuff. And over there in the resource, that's an Amazon resource name. It's this string with all the colons. It's a fully qualified name of a resource in AWS. You will notice that in S3, there's no region and no account name. And that's because S3, that you might see in the other services. Some of the things we'll see later will have those, but in S3, they're not there. S3 is one of the original AWS services, and so that's why the ARNs look like this. So this ARN here is talking about a particular object. It is talking about yellowsubmarine.json. Now, of course, that works great if you're going to be talking to yellowsubmarine.json, but if you're talking about a folder, which is, or a prefix, which is what we're going to be talking about here today, you probably want to do some wildcarding. So this policy over here, it entitles you to everything under yellow. That's great. Well, what if you also this caller needs to list out the contents of the object? Well, for that, there's an IAM action called list bucket. Now, just a note here, the API method that you call is probably called list objects v2, but the IAM action to go with it, they're usually in a one-to-one correspondence, but not always. And here's one of the places they're not. Is called list bucket. And the other thing to notice about this is something that people learning IAM with S3 often don't notice initially, is that when you are making that list request, the resource there, the direct object of that sentence is an ARN to an S3 bucket. Like the bucket is the thing that you are listing. So if I have that policy, then I can list the contents of example bucket. It'll show me all of the names of all of the objects in it. So back to these two accounts, principal in one account, bucket in the other account, it kind of stands to reason that both sides of this need to say that it's okay. And to sort of throw some technical terms in there, you have two authorities issuing policies, and the principal of the one is involved and the resource of the other is involved. So they both have to allow the access. So there's two authorizations when you have a cross-account access. There's the authorization for policies issued by the principal side. Does the principal side say this access is okay? And there are policies over on the resource owning side issued by that authority who has to say it's okay for this outsider to come in. If you think about it, you realize that's kind of how it has to be. So now, those of you who know your IAM, you know that there's actually a lot of other policies that come into play in this authorization here. There's policies on the virtual private cloud network. There's policies on the organization. There might be a permissions boundary. We're actually not going to talk about any of those today. But if you want to learn about those and the kind of coarse-grained security strategies you can do with those, I encourage you to look up AWS data perimeters. There's a great white paper on those strategies. We're not going to talk about them at all today. This is all about the fine-grained access once you have that part buttoned up. So these are the two policies in play for our purposes today because these are the two policies that can actually grant access. The rest of those strategies take access away. They create a perimeter. Conversely, when the principal and the bucket are in the same account, well, now we have one authority issuing policies. And so these policies get authorized in one go. We take the principal policy and the bucket policy, we authorize them together, and the rules of IAM is at least one matching statement needs to say allow, and none of them need to say deny. So what that means is that when we are doing the same account access, if either of them has that allow statement, and of course if neither of them has a deny statement, then the access is allowed. This distinction is going to come up in a few places throughout our talk, which is why I'm pointing it out here. Okay, so what we just said, we have a principal in IAM identity making a request to an S3 bucket, and there's policy issued over here, policy issued over there. So there's an authorization of the IAM principal policy. There's the authorization of the S3 bucket policy. Two accounts, you get two separate authorizations, and they're sort of ANDed. One account, one authorization. It's effectively an or, although, of course, the deny statements come into play for both of those. So those are your basics. Let's start applying them. Okay, so let's start writing some of these policies in our use case with the red, yellow, and blue folders. I have an IAM principal. It's associated with entities who should be reading this blue data. So I'm going to write them a policy like this. It's going to say get object, put object. They can read and write. I'm going to use that wildcard strategy. We already saw this, and if this blue IAM role makes a request to read blue ocean, well, that's going to work because it matches this allow statement. Now, they have access to the blue folder. They may also need to, if they're running some kind of analytics workload, they're going to need to figure out what's even in this object, what's even in this folder before reading it. So we're also going to give them permission to list the contents of the bucket, because that's kind of their job. So fine, this IAM role is going to call list objects v2 with the SDK that it's using. And what are we going to see here? Well, okay, we're going to see blue bird, blue moon, but we're also going to see the rest of the contents of this bucket. Red stuff, yellow stuff, right? Because they asked to list the contents of the bucket, so they're getting the contents of the bucket. So that might be okay. That might be fine. All they're going to see here is metadata. They're not going to be able to read the contents of redalert.jpg. What if I actually needed to restrict that list to just the blue folder? Well, I can do that. Over here, I've added a condition to my IAM policy. I say that they can list the bucket so long as the prefix that they're asking for starts with blue /. Okay, now note that IAM is a very literal policy language. It very literally, and straightforwardly, once you understand that it works this way, very literally concerns what request you can make. It actually doesn't have anything to say about what the response should be. So what this does is this does not take the contents of the response for a list request and filter them. No, it insists that when they ask to list the bucket, they must say the magic word. They must include the prefix for blue or something more specific than that. So this will work. This IAM role calls list objects, prefix blue, great, blue bird, blue moon, everything works. But if they go and they then make just an unqualified list objects, well, we no longer match this statement. IAM is very literally about what you can request, and here we get an access denied. So if you need to be specific about listing, it does need to work this way. So let's start a little bit of math, because we're here to talk about scale. Let's go back to that get object policy, and I've put this policy over on the S3 bucket policy, and I've written a very specific policy statement. You'll see here that this statement entitles you to read the blue folder data only if, exactly if, you are this particular IAM role. That's what that principal ARN thing does specifically. Okay, count up those characters, about 251. If I add the stanza, if I add the statement here for that specific listing thing, then this number grows to about 554. Those of you who are here at this talk, you probably know that the S3 bucket policy has a quota of 20 KB. And so if I do a little bit of math with that, make some estimates, divide some numbers, you land at about, if you wanted to describe your whole use case on an S3 bucket policy, you're going to be talking about 30 prefixes. That number's not exact. It depends how long your prefixes are, how many characters they consume. But we're talking double digits, not high double digits. Now, I will say here that if you fit within this scale dimension, listing out all of your permissions patterns on the S3 bucket has some very nice characteristics. You can look at the bucket policy and see exactly who has access to what. Now, so the scale dimension here is the number of, that bucket policy space that you need is going to grow linearly in the number of prefixes you have. So that's your scale dimension here. Now, what if you have a few more prefixes than that? Well, you might observe, we just talked about this, that the callers themselves, the principals themselves, they themselves have policies, and there's more of them. So could we instead get a little bit more juice out of our policy space by not trying to express everything in this singular monolithic bucket policy, but instead try to factor it out into the different IAM principles and what each of them should do? Okay, so let's try that. We'll have 3 IAM roles, red, yellow, blue. Each of them has an IAM policy on them. And you can imagine these policies are now actually fairly straightforward. We'll look at them in just about a minute. And back to these users, if these entities are actually users, we're also probably talking about some sort of identity federation into IAM. Now, if you work for a big company using AWS or even a small company using AWS, you're probably, even if you don't know that word, you're probably familiar with IAM federation because your company probably has some way of getting you mapped into IAM roles in order to use AWS, use the console, et cetera. AWS's own federation solution is called IAM Identity Center, used to be called AWS Single Sign-On, but there are a lot of other technologies that do that as well. Active Directory Federation Services, Okta, something that your company might have a custom thing that is built. All of that is possible. It's a way to map people into these IAM roles. So, I have a group of people on the red project being mapped into the red role and so forth. And now if I start to think about what policy I might put on each of these principles, I'm not going to run into, this is not going to run into any sort of limits on policy size, right? Like this is a fairly straightforward thing. Blue role gets to read the blue data. So this is role-based access control at its very core, RBAC. So you might be wondering, but there's someone in my organization, they're a member of both the red project and the yellow project, and they want to come into AWS and do something that sort of joins the data from both of them. So in one session, they want red and yellow. Well, what you're seeing here doesn't quite do that because this is role-based access. They need to choose red or yellow, one or the other. Well, I could solve that. I could make an orange IAM role for this combination of use cases. And when they're going to go in and do the combination of red stuff and yellow stuff, I can make a role just for that. And the policy for that isn't that much more complicated. Now, those of you who know a little bit of math know that I've just introduced an exponential relationship here, right? Like in theory, this is 2 to the n. In practice, actually, it may not be. If you just have a few orange, green, purple roles that you need to introduce into this mix, that might actually work fine. This is a pretty straightforward pattern, and it does actually get you more discrete use cases than the one we looked at before. So what's the scale dimension to be thinking about here as you're doing the math? Well, it's the number of unique discrete use cases that you have. That directly gets into your IAM role count. IAM role count, the quota that you need to think about is 1,000 per account. That's probably the number I'd be thinking about. Now, if you have just a few more than that, of course, you can use multiple accounts to hold these IAM roles. Of course, on the S3 bucket policy, you need to allow those additional accounts, but that's not really, I don't think that's probably going to get into complicated scale limits if you're just sort of doing that at a coarse grain level and letting the fine-grained access be done by the IAM roles. Now, there are some variations on this pattern. So what we just talked about here, we were worried about number of roles here, and we had red, yellow, blue, and, if I could think of 1,000 different color names, I would be out of IAM roles in one account. But actually, there's IAM. Those of you who are familiar with IAM and AWS, you know that IAM supports tagging of resources all across AWS, but what we're going to talk about here is tagging of the IAM principles of the sessions themselves. So with a tagging strategy, and if I'm worried about 1,000 IAM roles, either from a manageability, from a scale perspective, I could combine them. Because most of these federation solutions, including IAM Identity Center, can be configured to convey some of your directory group membership, like maybe you have users in a group named Blue, to convey that into a tag on the session that they have as they enter AWS. So I could configure IAM Identity Center to tag users who are in the Blue group with a tag project equals Blue. Okay, I could do that. So, and if they're from the yellow group, we tag them project equals yellow. Now I'm only using one role, but it changes tag depending on who's coming in. That's what the federation thing is doing for me. So I can write a policy about that. It's going to look a little bit like this. I'm over on the bucket policy side, and I am talking about being in the same account. Of course, if you're in a different account, you simply need to allow for the fact that you have other accounts allowed in. So over here, I've said they can get the Blue folder so long as the principal, the color is project tag says Blue. Now I want you, this gets very close into security in the cloud. I want you to know one very important thing I did in this policy. I had to also be specific about what accounts these tags can belong to. The reason for that is that anybody you could sit here right now and create an IAM role and tag it project equals Blue. And just because you did that doesn't mean I want to allow you into my bucket, no offense. This is the account that I trust their tagging scheme. I trust how they control the tags. So I want both conditions here. Must be from account 111, as well as must be tagged project equals Blue in order to read this data. But this is still, even though we're using tags, this is still role-based access here. Why? Okay, so what we've done here, tags are just key value pairs in AWS. So I can have nothing's infinite. I can get infinitely many different projects in here. I could have Blue, I could have chartreuse, I could have maroon, right? Like these are just strings, right? So I've basically removed the limit there. But notice that on any given session, that project tag can have exactly one value. So I can be Blue or I can be yellow, but I cannot, under this scheme, have a strategy that gets me both yellow and Blue. You could do it a little bit differently, though. And so this is a scheme worth considering if you sort of need these combinatoric patterns. And you're a good match for a tagging use case. You could instead of doing project equals Blue, you could do Blue equals true. Now, you still get a virtually unlimited number of project colors here. But the limit here that you would need to think about is, well, we'll look at this. I have side by side. On the left-hand side, I had the original tag policy that we looked at. You can have as many values for this as you want, but only one at a time. And over here, you can have this user over here is tagged both yellow and blue because they're green. And this would give them, if you had a similar policy statement for the yellow folder, they would have access to both. But the thing you need to think about here, the quota to think about here is the number of sessions you could have, number of tags you can have on any given IAM session, which is 50. So your use case might fit this just fine. It might be that the number of tags, number of projects, number of folders that anybody needs in any session simultaneously is a relatively small number, and then you can sort of build a federation solution that gets each user tagged with their appropriate combo. A few things to notice about is we're back to the bucket policy, so we still need to think about that 20 KB, and again, that 50 at a time. So you need to be smart about which you apply at the same time. So we have those two constraints here. So what we just talked about is how to get the most juice out of these static, role-based IAM methods that we have here. But I do talk to customers now and again where their scale, their use cases are these static patterns, like they are sort of static kind of role-based patterns, but they're way more numerous than anything we just talked about. They did the math here, they did the math there, their scale dimensions are well beyond what we just talked about. And for that, that's when to start looking at a technology called S3 access points. So this is a feature in S3. It's existed for about 3 years. And I'll sort of explain what it is before we get into sort of the techniques and the considerations for this use case. I'll talk about kind of when this might be something to look at. Okay, so we're back to our original picture here of different groups of entities needing to get to different folders, except we're gonna say there's a lot more of them here. And I went deep into my Crayola box in order to find all of these color names, so hope you like them. Okay, so I have this story, but it's a much, much bigger story than what I can fit on the screen. Now, what an access point is, an S3 access point is effectively an alternative endpoint to an S3 bucket. So this is sort of the mental picture to keep in mind. With an S3 access point, instead of, or in addition to, being able to request data directly referencing the bucket, you can instead reference this access point, which has its own DNS name that's generated by S3. We'll look at those in just a little bit. Your users can request data from the access point. Now, why would they do that? Well, the access point itself has an IAM policy on it. And you can have a lot of access points, up to 10,000. Which means we just added 4 zeros to the amount of IAM policy space we have at our disposal. So let's see what we can do with that. Okay, so back to our picture, all the crayons in the crayon box. Each of them, if we give each of them an access point and each of them a policy, you can start to think about how each of these discrete policies, for each policy, that policy is not itself going to be very big or very complicated. And you're going to be able to manage them separately, which has some manageability benefits as well. Okay, so let's look at exactly how the mechanics of an access point request work, because you do need to understand this if you're going to be using this to get those extra 4 zeros on your policy space. Okay, so a typical request here, this is just bog standard S3, we call getObject, and if you turn on the -- debug in your command line interface, which bracket, I recommend that you do independent of this talk. You'll learn a lot about how, if you're curious under the hood and want to see exactly how an AWS request works, it'll show you everything. But if you see at its very core, in that debug spew, you'll see that you're doing an HTTP GET request to examplebucket.s3.yourregion.amazonaws.com, and then the path. This is, S3 generates that DNS name for your bucket. So that's how you reach the bucket. So let's put a blue access point in front of this bucket. So we still have the DNS name of the bucket, is what I just told you, but that access point gets its own DNS name. It looks like this. It's named after the name that you assigned your access point. Also has your account number in there, .s3accesspoint.useast2.amazonaws.com. And then you get another DNS name as well. S3, when you create an access point, also gives you an alias for that access point. Now, the alias is a string generated by S3 that starts with your access point name and then has a bunch of auto-generated stuff after it. The interesting thing about this, it ends in S3 alias. Use this like a bucket name. It's basically like a bucketoid. It's not actually an S3 bucket, but it sort of quacks like an S3 bucket in terms of requests. So now I have this DNS name that looks like the DNS name of an S3 bucket, but it ends in S3 alias, and I can use that to address my bucket by way of my access point. You see, these kind of look the same, the request to an S3 bucket versus a request to one of these generated aliases. Okay, so how do I make a request to an access point? Well, I use that alias instead of the bucket. So when this user reaches the S3 bucket through the blue access point, they use that as the bucket name. Our SDK or command line interface translates that into the right DNS name, and they get their object. So back to this picture, let's look a little bit at how the policies work. So I have an access point. It's got its own policy, so I'm going to write a nice policy on that, allowing the blue users to access it. What exactly is going on? What's going on? Because there's 2 policies in play. In fact, In specific IAM terms, there's actually 2 authorizations in play. Now we're authorizing 2 resources. We're authorizing the access to the object in the S3 bucket as before. Nothing's changed about that, but we are also authorizing access to the access point, because that too is a resource. So let's look at how those work. So we have 2 policies, and we're going to look at them side by side. Over on the access point policy, this is where I'm doing my fine-grained stuff, because this is the one that really needs to scale. This is the one that needs the 4 extra zeros. So I've written a policy here. It allows reads from this other account, 444. And you'll notice that the ARN here, it looks like an ARN to an object in an S3 bucket with a few sort of key, with a little bit of a key change here. First of all, the ARN here, it looks like one of these modern AWS ARNs. It's got a region, it's got an account, it's also got this object in the path. You just need to know this when you're writing these policies. It's all in our documentation. And then over here, these callers on the blue project, they also need access to the bucket, because they're accessing both resources, so they need to say yes on both. The bucket policy, now I've written this a little bit differently. Now you could write the bucket policy exactly the way you were before, but then you don't get the scale juice out of that, because you're back to the scale limits we talked about before. So I'm going to write this one a little bit differently. I'm going to say, hey, I'm going to leave fine-grained access up to the access points in my account. That's account 111. So over here, I'm saying they can read my objects so long as they are coming through an access point that belongs to my same account. That's the first condition. The second condition, I'm also saying, I'm just going to make an invariant statement around here, like the callers have to come from my same organization, right? So I'm delegating all the fine-grained stuff to my access points. They're going to get to say who gets to talk to the blue stuff and who gets to talk to the dandelion stuff and all of that. The bucket policy is going to say, I'm going to trust the strategy on these access points to do that. Okay, now we are talking about a principal coming from another account, and as you remember, there's also going to be an IAM authorization over on their side. So what's that going to look like? Because remember, they're talking to 2 different resources. At the very bare bones, I could write a policy like this, right? I would need both of these resources. I would need the first resource here, which is access to the data in the bucket, and the second resource here, which is access to the objects by way of the access point. You could do this would work. But in practice, you might actually try to write something a little bit more scalable here, a little bit more generic. Because the fact of the matter is, what you're really trying to do on the caller side is you're saying, I know they have some kind of fine-grained access scheme over in account 111, and I just want to let them read the data from account 111, and let account 111 figure out all of this fine-grained access. So in practice, you might do something like this. AWS resource account, very useful in sort of these coarse-grained data perimeter scenarios, but also useful just as a scalability helper, right? Stuff owned by that account. Okay, so what we just talked about here. Access points, why you use them is because you get a lot more policy space and in these nice manageable discrete chunks. So you still have that S3 bucket policy in place. That's your best place for your perimeter statements, your deny statements, all of these things that assert nobody from outside my organization can get my data. The data that gets uploaded must be encrypted. Data must be accessed from these particular networks. These sort of broad-based, coarse-grained, not fine-grained statements. These sort of deny statements, things that can't happen. And then they can delegate within those boundaries all of the fine-grained access to these 10,000 access points that you can have. So best fit use cases these are still discrete, static, kind of role-based sort of access patterns, but they're very numerous. This helps you do that. And there's a number of use cases that fit really well here, like you have lots of subscribers to your data, something like that. Also, when you want to sort of separate duties between the people who are just sort of defending the data in the S3 bucket, like making all of these deny statements, versus all of individual data owners that need to make grants. Sort of helps you separate duties and maybe not bottleneck as much on sharing data. 2 things to think about when evaluating this use case. First of all, if you have some kind of catalog, either lowercase c or uppercase c of your data, that catalog probably refers to locations in S3 relative to an S3 bucket. Now, of course, here you're going to need your clients to actually access them through that alternative alias. So you probably are going to find yourself needing to make changes to your catalog or whatever other discovery mechanism you had. So that's something to keep in mind here, is that the way that the clients access the data actually has changed here. And the other part of this is that you do get 10,000 of these, and that's a nice high number. But this is best suited for kind of static use cases that don't really be changing on the fly, aren't dynamic, certainly don't involve your own business logic. But you might be wondering, what if they're dynamic? Maybe you do have access patterns that are dynamic, that are combinatorially large, that maybe involve some business logic that you can't even encode into IAM. So you're even past this scale dimension, because you're past this scale dimension of how dynamically things change. So what can you do? Well, the next pattern here, this is the dynamic pattern. This is sort of the default statement of this is the sort of the default switch of our case statement here. So this is what I'm about to describe is actually, it's not an AWS service, but it's a pattern that I've seen a lot of customers build that you might find yourself building, that's fairly straightforward and actually gives you a ton more flexibility in terms of arbitrary levels of flexibility in terms of what you can do with granting access to your data. So often when I talk to customers who, they have kind of a none of the above sort of a use case. They don't fit into these static use cases. Something's dynamic, something involves business logic. The first thing they often think of, they're like, okay, well, why don't I put a proxy in front of S3? I could do that. Instead of making requests directly to, getting into an IAM role and then making a request directly to an S3 bucket as one does, I could instead build this proxy. My proxy could actually do authentication however it is of users, however it is I want to do authentication. My users are going to come to my proxy, request their data. I'm going to make whatever policy decision I need to make, maybe with some business logic. And then I'm going to, if yes, I'm going to go to S3, get their data, and give it back to them. This totally works. And I see customers do this pattern, but the one thing you would think about with this pattern is the scale, right? This means that your proxy is on the hook for shoveling all of the bits back and forth. And S3, the thing it does well, or of many things that it does well, but a thing that it does extremely well is scale. Lots of bits. S3 is huge, and as a result, you can actually handle quite a lot of throughput for you. Now, of course, if you put a proxy in front of that, your proxy needs to scale for that too. That might be fine. It really depends on how much data you're going to have, but there is another pattern that if you've ever thought about doing something like this, there is another pattern you should be thinking about. And this gets into the mechanics of IAM roles, which I'm going to actually very quickly review here. An IAM role, as you probably know, is an IAM identity that doesn't have long-term credentials of its own. In order to be able to make requests, in order to be able to sign requests, it needs to be issued temporary credentials, and these credentials are always temporary. They always expire at some point. It needs to get temporary credentials. Now the question is, how does it get temporary credentials? Because typically an IAM role, I'll give you the example of a user here, but the similar pattern's actually true when IAM role credentials are issued to your EC2 instance, to your Lambda function, to all of these compute services in AWS that deliver temporary IAM credentials to your application. So what happens here is a service called Security Token Service. This is a service that's closely related to IAM. It's what we'd call a data plane service, so it exists in each of the AWS regions. Its job, it has an API called assume role. Assume role basically means issue some credential. I'm bringing you some original form of identification that STS will validate. I'd like you to give me some credentials to use this role, for a certain amount of time. So that's what assume role means. That's what STS does. And so then some temporary credentials are delivered back to this caller. They get to act as this role for however long until these credentials expire. So imagine I have an IAM role here, and rather than all of these fine-grained strategies that we've talked about up until now, instead I'm going to give it something broader. I'm going to say, here's a central IAM role. It has access to a superset of all of these. But I'm not going to let anybody assume this role directly. Instead, I'm going to have them through a broker that I build, and this is what we're going to talk about. I'm going to have them call STS, assume the role, get some credentials. But one of the things you can do with this assume role call is in the moment that you're creating this session, these credentials to give to the caller, you can further narrow down the permissions. So over here, I've given it a policy that, now we know how to read these policies. This policy means I get to access folder under example bucket. And the resulting credentials here are actually going to be the intersection of these policies. In other words, when this caller gets these permissions back, they don't get like full run of the IAM policy on that principal. They don't get full run of the bucket. They get access, they get object access to that folder prefix. Now this is a very powerful thing. If you can get in the middle of that assume role call, you can start making policy decisions and decide who gets what specific policy. So rather than building that proxy or that data access gateway, you can instead do something like this. You still have to build something, but you're building a much smaller, lower request rate, much lower volume in terms of the bits you handle back and forth, so much less demand for networking and compute and so forth. You put your logic just into that policy decider. Figure out who has access to what when they request it. If they have access, you go to STS to get a very finely scoped session for them for exactly what they're asking for. For right now, you get them some temporary credentials. And then they take those credentials and they go directly to S3. So your session broker input is some form of authentication, some kind of request, some form of authentication that you understand, what they're trying to access. You make a policy decision and you send back not data, but IAM credentials. And then your users are going to S3, and this is what S3 does best, because they're going directly to S3 and getting the full scale, the full mega scale out of S3. So I'm going to quickly sort of pseudocode out what this broker does. And if you find yourself in a situation where you're building one, this is the pattern that they all follow. So your users are first going to go to you, make a request with some sort of authentication token asking for some prefix of S3 data. You're going to authenticate them, however it is that you do, maybe against your directory or something like that. Figure out that they are who they say they are. You're going to make an access decision. This is where your business logic or all of those dynamic things come in. Anything you can do in code can be done here. You make an access decision. Should they be able to access this data? If yes, you're going to go on and you're going to assume that IAM role. So that IAM role is only assumable by your broker. It's not assumable by this caller over here directly. They have to go through you. You assume that role, and you scope the session for that role down to exactly what they're about to do. Give them a good expiration time on it that will serve whatever it is that they're trying to do. You return the STS credentials. You return these IAM session credentials to your caller, and then your caller goes to town with S3. So this is how it works. This is how it works. And typically, depending on your use case, you'll have to figure out what the scale of the session broker is, but the requests in and out to it are tiny, and they're typically going to be made on the scale of minutes by each user, rather than having to get in the middle of each and every request to S3, which can be quite rapid fire. So this pattern is extremely effective for that catch-all of, we have a dynamic access pattern. We want to get all of the scale we can out of S3, so we don't want to put something in front of S3 that we then have to scale similarly. And we just need lots of flexibility in how we do this. So this is a really common pattern. And so if you find yourself in this pattern, I hope kind of these directives sort of help map out what you would need to do here. So finally, I'm going to finish out by talking about, you'll notice that I put lake formation on the side of this little infographic here, and that's because it's not really on that spectrum of scale and complexity that we talked about here. I'm actually going to talk about a different and common shape of use case here. We're going to talk about what you do when your use case fits this shape. This is not really a deep dive into lake formation. This is rather just to sort of introduce you to kind of the sort of use case where I think this would be a very good AWS service for you to look at because of how it is shaped. So the fact of the matter is S3 is a storage service. So for all we think about like what's in our data in S3 and what it means to us, in S3, it's just an object. So you might have an object that ends in .snappy.parquet. S3 thinks that's great for you. And now you know that this is a Parquet, this is in the Parquet format, meaning it's probably structured data. It means it probably corresponds to some kind of table, has some schema. S3 doesn't know anything about it. It knows whether you do or don't have access to this yellow part 00 snappy.parquet. And then if we look inside those objects, I'm actually going to show you the contents of a CSV file just because that's easier to look at in a slide and understand what's going on, but same is true for any of these other structured formats, Parquet, JSON, et cetera. You know, if I look inside my CSV object in S3, now S3 doesn't know what a CSV is, but you can look inside that, and you can see that, well, this definitely does look like a table. Actually, it looks, you know, this is what's going on in this object. Now, if you think of your data in S3 in terms of schema, in terms of tables and columns and rows, your interface to the data, until now we've been talking about applications whose interface to the data in S3 is get object and put object. It's reading data on the object level. And if we're going to talk about any sort of organization scheme, we're talking about wildcards and prefixes and slashes and object names. But here, if you think about what the interface is to data that looks like this, it's actually probably more like a select statement, right? If you wanted to get the data out of that table, sure, you could read it and write a script, right? But you're actually probably thinking in terms of select something from this table, where something, right? So a great service that does that in AWS, that does that totally serverlessly, is Amazon Athena. If you have structured data in S3, this is a great thing to know, but if you have structured data in S3 and the way you want to talk to it is in terms of SQL queries, you can pull right up to Athena. And it's very simple to get your data cataloged in its sort of sibling service, the Glue data catalog, to get the data cataloged with its schema and then be able to just make these queries the way you think about it with Athena. And Athena's serverless, so it figures out how much compute to spin up to do the mass read of S3 that it's going to need to do. So it's a very convenient, quick way to get insights out of your structured data in S3. And the way you talk to Athena is you don't say get object anything. You go to Athena, you make a SQL query, right in that nice prompt it gives you. And Athena, of course, behind the scenes, and in fact, making onward calls with your original identity so that you still have to have permission to the underlying raw data in S3, it's going to go make a bunch of get object, list bucket, get object calls to S3. If you turn on logging, you'll see exactly what's going on. So Athena, of course, is doing a SQL query. Your SQL query is probably going to be talking about columns and so forth. So it needs that data, needs the schema of this data declared somewhere. That's where the Glue data catalog comes in. So if I have this table in the Glue data catalog, and I actually go and maybe look at it in Glue, so I've made a command line interface request to Glue, just tell me what you got for this table. You'll see that its schema is there. There's columns, there's types for the columns. It also tells me exactly where the raw data is in S3. If you wonder how Glue figured this out, it's because I put it there. You can either put it there manually, or even easier, you can take a Glue service called the Glue crawler. You point it to your S3 data. You give it an IAM role so that it'll be able to read through all that data. It groks the data and it figures out what your schema is and puts that entry into the Glue data catalog. So that's a really easy way to get your data quickly queryable by Athena. And since my interface to this data now is no longer get object and put object, where my permissions will be in terms of prefix matches in S3, I'm now handling this data by its schema, which means I probably want to be able to do permissions on that basis. I probably want to talk about who should query which data. I might even want to talk about who should be able to see which columns in a given table. I might be selective about that. And so over here, I've shown you a screenshot of the lake formation permission. So lake formation is kind of a sibling service to the Glue data catalog. And it lets me do a bunch of grants. These are grants that you might recognize, for example, the kind of grants you would make on a database. Grant select, grant insert. And the interesting thing about this is lake formation can give me column level, even row level, cell level permissions to my data. So over here, I've creatively have two users here. I have an admin user who should be able to read the whole table, and I have a user named SomeDataUser who should be able to read just the ID and price columns of that table that I showed you. So this is what I intend to have happen. Again, I'm expressing these permissions in terms of tables and schema now. Over on the left-hand side, the admin goes and makes a select star, and so I want them to see all the columns. Over on the right-hand side, the some data user comes in, makes the same query, but I want them to get a different answer. I only want them to see the columns that I've, they are restricted on what columns they can see, so I only want to show them the columns I can see. So we just spent almost the entire hour talking about IAM. We're IAM pros now. What do we put in this IAM policy? What do we put in this IAM policy? I'm going to think about that a little bit. Hey, that's a trick question, right? You can't do that in IAM. Why can't you do that in IAM? Because I'm trying to say something about how the output should look. And if you remember, IAM is a very specific language about what requests you can make. So IAM and S3, they know what this object is, and they know whether or not you have permission to read the object. You either do or you don't, but there's no such thing as you have permission to read half the object, right? IAM and S3, neither of them is able to filter this data the way you want to for these kinds of schema-based permissions. And over here, some data user can only read ID and price. So that requires a level of filtering that's kind of one layer up from what we can do with these basic services of IAM and S3. So I'm actually going to, since this is sort of a details talk, I'm actually going to show you exactly what's happening. And if you remember our previous session about IAM session brokers, you might see some patterns here that are familiar. So Lake Formation has integrations with a number of AWS services. I'm showing you Athena here because that's I think that's sort of the easiest one to sort of go through as an example, and probably something that you use to query your data in S3 along with some of the other integrations. But over here, here's Athena. Here's an example integration. Some data user pulls up. They say select star from demo listings where price is less than 140. Athena speaks SQL, so it's like, okay, great. Let's get this query started. But of course, this data is permissioned in Lake Formation. So the first thing Athena does, before it even starts reading all of this data and parsing it and doing whatever it does, it goes to Lake Formation and says, hey, some data user is going to make a select query on this table. What do you think? And Lake Formation, this all happens under the hood. So this is AWS services talking to each other. Lake Formation says, okay, they can access it, but they only get to access the ID and price columns because that's what my permissions say. The other thing Lake Formation sends back to Athena, it says, and you know what? That data, since Lake Formation and Glue code go together, that data, I looked it up in the Glue data catalog, and it's over in this, it's at this specific S3 location. That's where you're going to need to do all your get objects. And here is an STS credential. Here's an IAM session that will give you access specifically to that data in S3. Now to go a little bit more into the details, whose IAM role is that IAM session on? Well, it's an administrator of Lake Formation would have registered that S3 data with an IAM role that's entitled to read it. And Lake Formation is vending these very, very scoped down sessions into Athena to be able to read that data and perform this query. So Athena then goes to the Glue service, makes some API calls to it to get the schema and whatever it needs to know to execute this request. And it then goes and takes that STS credential, does a bunch of list bucket and get object over at S3. And that's exactly what happens here. Athena then, because it's this query engine that understands how to do a select query and also understands how to execute these these non-IAM filtering directives from Lake Formation, it then goes and executes the query, filters all the results, and so what our some data user sees at the end is exactly what we wanted them to see. So this is kind of this IAM session broker pattern, except done by an AWS service plus, because they're also doing this filtering. So with Lake Formation, where to look for Lake Formation in your use case is when your use case has structured data, and really the kinds of permissions that you are trying to grant are really more easily expressed in terms of database grants and select, and you need to talk about columns and things like that that you can't even talk about in IAM at all. So we just talked about think 4 different categories of use cases and their associated strategies and when each is, how to do each strategy, when each is appropriate. So to kind of go back over that, like how to choose among all of these different strategies we talked about, these are all advanced strategies. Well, if you fit within the IAM basics, which many use cases do, you stick with that. That's straightforward, that's simple. If you know what you're doing with IAM, you're gonna get it right. You can sort of take those patterns, you could take an S3 bucket and make it just like a full manifest of who has access to what. If the number of prefixes, the number of folders you're talking about goes up to, we said about 30, low double digits, that's actually a very straightforward way to manage that. Getting a little bit higher up that scale ladder where we have a little bit more than that, so we sort of need to factor that out. One place you can factor out these discrete permissions is onto your IAM roles. You can have, more IAM roles, each with a fairly straightforward policy of its own, and sort of break it down that way. We also talked a little bit about, tagging kind of strategies on that to be able to get a little bit more flexibility and scale in different dimensions out of IAM roles. Once we were sort of past the quotas of what we could do with both IAM principles and S3 bucket policies, then we started to look at S3 access points. S3 access points are for use cases that are fundamentally shaped the same way as IAM in the sense that they're sort of discrete and role-based, but they're very numerous. So S3 access points gives you way more scale in terms of how many of these discrete use cases you can assign permissions to. And finally, when we got to sort of a none of the above, or it was too dynamic to be able to express in these sort of role-based patterns, or just simply involved business logic of your own that you couldn't, that can't be encoded into the IAM system. Then we started to, we talked a little bit about this IAM session broker pattern that you might end up building, with a little bit of guidance about how to build such a thing. And then finally, off on the other side, we talked about structured data. And when your access patterns to your data in S3 really look like SQL queries, and your permissions are really in terms of schema, I would definitely look at lake formation, which is is a permission system for structured tabular data in AWS. So that is what we talked about today. We did cover a lot of ground today. We went a little fast, and everything I talked about today, there's great training material if sort of trying to brush up on your IAM basics, wonderful training material all throughout AWS, storage in particular, and actually across the whole AWS portfolio. So I would encourage you to further dig into any of these. It seems like it fits your use case. So thank you so much. So glad to see you here at reInvent, and I hope you have a great rest of the conference. Enjoy the party tonight.